All right. I have Raheem, who has volunteered to work this problem for me. Say hi, Raheem. Okay. So what we're doing first is we're graphing linear equations using the intercepts. Let's go. Nice and loud.
Take 16, you subtract from both sides, correct?
Okay. So this time you can do that, but we're graphing just using the intercepts. What are the intercepts? Okay. There is an x-intercept and there is a y-intercept. Tell me what you mean by that. If I have a graph and this is the equation, point to the y-intercept. No, this is actually the y-axis. What's the y-intercept?
Oh.
Good. That's the point where your graph actually crosses the y-axis. You got that?
Yes.
Okay. The x value of that is what? Tell me. The x value of the y-intercept is what? What's the x value? No. I'm asking you, what's the x value? For a point to touch to be on the y-axis, the x value is what?
0.
Right, because we start all points from here, right? But to be on the y-axis, do you go to the left or to the right? No, so the x value is always 0. And y is what it is. We call it b in general. Okay? All right, we clear on that? What's this line called? The x-axis. And Raheem, point to the x-intercept. Good. So when you have an x-intercept, the y value is always what? 0, because you don't go up and down in it. Okay? So if you're going to find the y-intercept, what do you do?
For the x.
Okay. To find the y-intercept, what do I do? Either one. If I'm graphing using the intercepts, I want to find two specific points. I want the y-intercept and the x-intercept. Okay? So you can always graph an equation using a t-table. Okay? But to find the y-intercept, what must be true? Say again? If they were the same, then I would have like 1, 1. That's not on. No. What did y'all just tell me? If I find the y-intercept, what must be true? The x value is 0. Okay. Thank you. The x value is 0, so put it in. 4 times 0 plus 16y equals 64. Alright? So this is 0. So 16y equals 64. So y equals 4. So that's the y-intercept. Are you okay with that? Come and ask me a question. Okay. I want to capture your question.
So,
so to find the y-intercept for any problem, we do what? Write 0 for what? The x value. You put in a 0 for the x value. This is the y-intercept. But any equation.
So,
okay, good question. We have 0 plus 16, y equals 64. Okay, I'm solving for y, right? 16 is what? to y? Is it added to y, subtracted, multiplied, divided by? It's multiplied by y. So to eliminate the 16, I need to divide by 16. What I do on one side, I do on the other. Okay, you good? The other point that I need, this is my y-intercept. The other point I need is my x-intercept. Perfect. See that right here? For the x-intercept, y is 0. Okay? Yes? Okay, so handle that one. Okay. You want me to erase this so you have more space? Okay. Okay, I'm gonna erase it so you have more space so you're writing downward. So that if anybody views this video, it'll be nice and clear. Thank you. 16. Good. So the x value is 16. Okay. So if they told you to use the intercepts to graph and you scale by ones, you got to make sure you understand what scaling means. What scaling means? No, rise over run is what?
That's the form of slope.
That's slope. Rise over run is slope. Scaling is what you choose to count by. So you count by ones, each little tick represents one. Okay? So I'm plotting the point 16, 0. So if I'm scaling by 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's 16, 0, right? And if I'm scaling by ones on my y-axis, 0, 4. Once you put your points in, gosh, I have problems graphing. It'll create your line. But they want two specific points when they ask for the y-intercepts. Okay? All right. Okay. The question is, are they going to ask for the x-intercepts too? When they say generically, graph using the intercepts, they want the y-intercept and the x-intercept. Great question. So that's why we found the y-intercept and the x-intercept. We did not use rise over run. Or we did not use slope intercept, but that's where we're going in our next video.